Okay, this is N1IR, and we're just discussing, this is video number 2 of the Clocket kit, and doing a little bit more digging. I actually found the C file that this thing is programmed with, and it doesn't look like it's Arduino compatible, but it looks like it was programmed in AVRDude, and looks like it's common anode here in the notes, up here in the comments. Basic alarm uses 4-digit 7-segment display, includes alarm snooze. Alarm will turn back on after 9 minutes if alarm is not disengaged. Alarms through a piezo buzzer, 3 input, up, down, to snooze, 1 slide switch. And this is very interesting. I had this in back of my head. There's no current limit resistors for this, and what they do is they do a little bit of pulse width modulation. So they send a series of square waves, and that timing of on and off determines the brightness of the LED. So I thought that's very interesting. Usually when you do 7 segments display, you need a resistor for each segment. So you're talking 7 times 4, that's a lot of resistors. So what he did here is he actually used some pulse width modulation. Excuse me. And this is all available. This is the C. And you're going to need a compiler if you're going to change any of this. Change that from C and compile it to hex. In the zip file they also give you the hex file, so if you use LadyArt as programmer and AVRDude, you should be able to program this without any problems. So unfortunately it's not Arduino compatible, but that's okay anyways. Looks like he's using some C, which is a little bit better than the Arduino language. And that's the whole thing. And here is your look up, look down table for the segments, different cases for, looks like there's an AM dot. You can change the time, you can change brightness level, so you can change a lot of things in the programming here, which is pretty nice. It's nice, all of it's all commented, which is a very much plus. Thank you, Nathan, on that. Nathan's the one of the guys that wrote the software. So that's it. So this is going to be video number 2, and this is the actual IC I was telling you guys about. This is the original MM5314 clock IC. I have about 20 of these left, and this is actually a lot more complicated than the Clocket kit. This one you actually have multiplexed, and you have to go through driver transistors and to your 7-segment displays. And usually I do this on 2 boards, and on the display board is double-sided PC board. So you connect all the A's together, all the B's together, all the C's, and you connect all the commons and multiplex them all on and off. Now the thing on this one, it uses the 60 Hertz coming in from the wall. And as of about, I would say about 15 years ago, they deregulated all the electric companies, and they no longer have that tight tolerance of 60 Hertz in the US. This can run off of 50 or 60 Hertz. 50 Hertz is over in the UK, 60 Hertz is over here in the US. So back in the 60s and 50s, 70s, and maybe mid-80s, from the wall outlet, you had plus or minus 1 Hertz, 60 Hertz. So it can go up or down 61 or down to 59 Hertz. And after deregulation, that tolerance went out the window because no one's using these things anymore. Everyone's using the microprocessor-based clocks now that use the crystal as a time base and divide it down. So that's the nail in the coffin for this guy here. I've built this up, and it does change. You lose a few minutes a day actually, because for the electric company they ramp up the frequency to make it cheap to go through the line, and that's why they vary the frequency up and down. You know, a few hertz makes a difference when you're transmitting thousands of miles. And yeah, that's it, guys. This was made in 1985, 4th month, 1985. Still some available online. They charge like 20 to 40 bucks for these. And that's it. That's 70s technology. This is today. So big jump. And it's very interesting that they use pulse width modulation instead of current limit resistors. Very, very smart idea on that. That way you reduce your parts count. And I was wondering how they did that. So big thumbs up on that. Really impressed with that. So this is video 2. I'm going to go on to video 3. I'm going to assemble this thing and again figure out the pinout on this. It still doesn't tell me the pinout, but at least it gives me in the direction of what type of, if it was a common anode or common cathode. It's actually a common anode. So I'm going to test that out, common anode, with the meter and figure out what pin go to where, and hopefully find another substitute for that. See ya.